All right, number 6, find the domain and range of the function, and we've been given f of x equals 9x squared minus 108x plus 327. And we know, again, that this is a quadratic equation, which means if we were to graph this equation, we would have a parabola that opens up. And just like we talked about in number 5, question number 5, all parabolas that open up or down have a domain that is from negative infinity to positive infinity. All right, so again, if your parabola opens up or down, the domain for that parabola will be negative infinity to positive infinity. However, to find the range, we have to do a little bit more work. And what we want to do is first find the vertex, all right? And we want to find the vertex because the y value from that vertex is going to help us to find the range. And we can find the vertex in one of two ways. And I think what I'll do is, just like with question number 5, the first video I completed the square, and then the video after that I showed an alternative method to finding the vertex. So I'll do that again here. So we've been given an equation in standard form, and what we want to do is go from standard form, so from standard form to vertex form. All right, and vertex form is nice because you can quickly identify what your x and y are from the vertex, all right? And as we talked about in video 5, we're going to complete the square. So let's start and rewrite what we originally had here. And just like before, we went ahead and we grouped the first two terms together. We grouped our x's together. In this case, however, notice that the coefficient of the square term, this x squared term, is 9. So we have to factor out that 9 because when we complete the square, the coefficient in front of the x squared can't be anything other than 1. So when we factor out that 9, what we're left with is x squared minus 12x plus 327. All right, and again, I mentioned before that when I complete the square, I like to go ahead and include some blank lines to help me remember what it is that I'm doing. And I'm running out of room, so I'm going to just move this over a little bit. All right, notice that we're going to be adding some number inside, and we're going to be subtracting some number on the outside. So let's figure out what numbers we're going to be plugging in here. We know that when we complete the square, we have to take half the middle term. So half of negative 12 is negative 6, and then we square that number. So negative 6 squared is positive 36. That's why it's plus 36. And now we have to subtract some number on the outside. Now be careful here. We're not subtracting 36. It looks like we're adding 36 inside, but what happens if we were to distribute this 9 back through? We're really adding 324. 9 times 36 is 324. So since we're adding 324 to this right-hand side expression, we have to subtract 324 on the outside. All right, and now we'll go ahead and finish up here. Now that we've completed the square, these three terms are what are known as a perfect square trinomial. We can go ahead and write these three terms as a perfect square binomial. So we'll have x minus 6 squared, and then 327 minus 324 is positive 3. All right, and now that we're in vertex form, we can quickly identify our vertex as being 6, 3, 6, 3. And if this parabola opens up, which it does, we know that this vertex is the valley. It's the lowest, the smallest point on this graph. And so the y value, remember we're finding range, the smallest y value will be 3. And if the graph opens up, well, then the y values are going to get bigger, aren't they? So they start at 3 and they tend towards positive infinity. And so we have bracket with our 3 and parentheses with our infinity. All right, so this is method 1 of finding the domain and range. If you don't like completing the square, and this one had some bigger numbers in it, so you may not want to complete the square with this one, go ahead and take a look at the next video in the playlist, and we will find the vertex using an alternative method. But for number 6, domain negative infinity to positive infinity, and the range positive 3 towards and up to positive infinity.